To add and subtract complex numbers, simply add and subtract the real parts and the imaginary parts. For example, to add 4 plus 5i to 3 minus 2i, add the real parts, which is 4 and 3, to give you 7, and then 5i plus minus 2i, we add those, we get 3i. So our answer would be 7 plus 3i.
Now here we're given two complex numbers to multiply, and if you didn't know I was the imaginary number, you think this is two binomials and we're going to FOIL it. Well, actually you can FOIL this as well, even though I is an imaginary number. So let's see how we do that. We'll get 2 times 3 gives me 6. That's the first. And then we'll get outer 2 times 4i. 2 times 4i gives me 8i. So we have plus 8i. Then the inner product is 3 times I plus 3i plus 3i. And then the last product would be I times 4i. They're both positive, so I times 4i is 4i squared. So this would be 4i squared. And now we can simplify this expression here. We'll have 6. 8i plus 3i is 11i. And interestingly enough, I squared is negative 1. So we can replace the I squared with negative 1. So we'll have plus 4 times negative 1. In other words, we're going to subtract 4. So this is going to be a negative 4. And so 6 minus 4 will give me 2. So we end up with 2 plus 11i, which is a product of 2 plus I times 3 plus 4i. But remember, I is the imaginary number. Now let's look at some division. Suppose we want to simplify, do the division 4 plus 6i divided by 2. Okay, well we could divide 2 into both terms on top, so that's 4 divided by 2 plus 6i over 2. And 4 over 2 is 2, plus 6 over 2 is 3, but you have that I there. So that would be simplified to 2 plus 3i. Suppose you're dividing by a complex number. Here we have 9 divided by 3i. What do? Well, we know 9 divided by 3 is 3, so we can actually write this as 3, but the I still is going to remain in the bottom. And we're not used to writing complex numbers with the I in the denominator. So we can do what we actually did, similar to what we did with rationalizing the denominator. We multiply the bottom and the top by I. So I over I, same thing, is 1. So we haven't changed anything. But what we're going to end up with is 3 times I is 3i. And on the bottom we're going to have I times I, which is I squared. But we might remember I squared is negative 1. I squared is negative 1. So the bottom is actually negative 1. So this is 3i divided by negative 1. And dividing 3 divided by negative 1 is negative 3. So we actually have negative 3i. So that is our simplified version of 9 over 3i, negative 3i. So this is very useful when we're dividing by a complex number. Here we have 10 minus 2i divided by 2i. So we can actually split this up as divide the 2i into both the 10 and the negative 2i above to get 10 over 2i minus 2i over 2i. And 10 over 2 is 5. And 2i over 2i is 1. So we'll end up with 5 over I minus 1. Now remember, here we have an I in the denominator. So we don't really want to have that I in the denominator. We prefer it to be in the numerator. So what do? Multiply top and bottom by I. And so we end up with 5i over I squared minus 1. And remember, I squared is negative 1. So this is going to be equal to negative 5i minus 1. Or if you want to put the real part in front, this is going to be negative 1 minus 5i. So that would be the end result of our division. This last problem, where we have two complex number in the form a plus bi and we want to divide them, involves all the steps we've used before. So we have 6 plus 2i divided by 2 plus I, and I want to do that division. In another way of thinking about this actually is we're going to simplify this rational complex number. And the way to do that is we have to multiply by the conjugate of the denominator. The conjugate of the denominator is 2 minus I. So we're going to multiply top and bottom by 2 minus I. And that's kind of like how we rationalized the denominator, where you had a binomial in the denominator. So now we have to do our multiplication. So if we multiply the top, we're going to have 6 times 2 is 12. And then 6 times minus I is minus 6i. And then 2i times 2 is plus 4i. And then 2i times minus I is minus 2i squared. And on the bottom, what we're going to have is 2 times 2 is 4. And 2 times negative I is negative 2i. 2 times I is plus 2i. And I times negative I is negative I squared. And now we have to combine like terms. Here we have a negative 6 plus 4, which will give me a positive 2. Sorry, a negative 2. And here we have a negative 2 plus 2, which will, what? Cancel out, which is a good thing. So let's simplify this. The simplified version is 12 minus 2i minus 2i squared, and then 4 minus I squared. 4 minus I squared. Now, remember, I squared is negative 1. So if I make put a negative 1 here and here, in other words, I change the signs here to plus and plus, what we end up with is 12 minus 2i plus 2, and then 4 plus 1. So this negative 2i squared becomes plus 2, and this negative I squared becomes plus 1. And then we can combine 12 plus 2 to give me 14, and 4 plus 1 to give me 5. So what we get is 14 minus 2i, 12 plus 2 is 14 minus 2i divided by 5. And then now we can simply divide 5 into both numbers above to get 14 fifths minus 2 fifths I. And that's our final result from our division of those two complex numbers.